For this demo, we will connect transmit SDR channels to the scope and confirm the output makes sense. You can see the bottom SDR unit is plugged straight into Fluke oscilloscope. Let's run the generator. The generator itself in Python, but I will be calling it from a Python notebook, from Jupyter notebook with the bash kernel. So first I will send exactly the same pulses on both channels, no phase shift, no jitter. Yeah, it looks quite sane. Let's try something a bit more complicated. Now it's phase shift 1 millisecond and 250 nanoseconds jitter. Yes, the scope is auto-calibrating now. And let me zoom to the screen. Okay, it also looks reasonably correct, so it jumps around 1 millisecond delay. Now let's disconnect the scope and send the signal to receiver SDR unit and capture and analyze the data. Now we have coax cables carrying the signal from the TX unit on the bottom to the RX unit on the top. We will run 5 tests. During first 2 tests, we will send identical pulses to both channels. We expect to see very small relative delay. Then we will add the delay and the jitter and make sure our receiver and analyzer catches it correctly. The measured signal should match parameters we pass to the generator down to 10 nanoseconds or so. Here we have a Jupyter lab. I've prepared 2 separate notebooks, one for signal generation and another to capture and analyze the signal. This is because we need to run generator and receiver simultaneously, and there is no easy way to do it from a single notebook. Let's start the signal generator first. Here the Python script generates 2 square waveform signals with given parameters and send them to the transmit SDR over Ethernet. We didn't specify any parameters, so the signal will be identical. The TX SDR will convert digital waveform to analog signal and send it over coax cables to SDRs. Let's start the receiver. You can see that this Python script also connected to USRP and started getting the signal. It in real time gets the samples and detects edges and saves edges timing in the file for later analysis. The receiver ran for 10 minutes, crunched through 6 billion samples. Let's analyze the data. The script which analyzes the data has to match 2.5 million samples edges, so it will take a little while. Now it's done and we can look into final report.